Alright, let's talk about something you see every single day. You probably don't give them a second thought, not until one goes flat on a rainy Tuesday morning. I'm talking about car tires. Those black, round things that connect your several thousand-pound vehicle to the hard, unforgiving road. Ever stop to wonder how these crucial components actually come into existence? It's not magic, folks. It's a down and dirty, hot, and surprisingly complex process. From a pile of raw stuff to a perfectly formed circle of safety, it's a journey worth looking at. These aren't just simple rubber rings, they are engineered marvels, designed to grip, flex, and endure. You see them on every car, truck, and bus. They spin countless times carrying us to work, to school, on vacation. But the story of their creation is a fascinating tale of science, heavy machinery, and good old-fashioned hard work. It involves transforming sticky, raw materials into something incredibly strong and resilient. Think about the forces a tire withstands, the weight of the car, the heat from friction, the impacts from potholes, the constant flexing. We're going to peel back the layers, literally, and see what it takes to make one. So buckle up because we're diving into the nitty-gritty of tire manufacturing. Let's get our hands dirty and find out how it's done. So what's actually in a tire? It's not just plain old rubber, not by a long shot. The main ingredient, the backbone, is indeed rubber. But there are two main types used: natural rubber and synthetic rubber. Natural rubber comes from the sap of rubber trees, primarily found in Southeast Asia. It provides excellent elasticity and strength, which are pretty handy for something that needs to absorb shocks and grip the road. Then you've got synthetic rubber. This is man-made stuff, cooked up in chemical plants. There are various types like styrene butadiene rubber, SBR, and butyl rubber, each with its own special talents. By blending natural and synthetic rubbers, manufacturers can fine-tune the tire's performance characteristics, getting the best of both worlds. But rubber alone isn't enough. To give a tire its signature black color and, more importantly, its incredible strength and wear resistance, you need carbon black. Silica is another important filler, sometimes used alongside or instead of carbon black, particularly in high-performance or fuel-efficient tires, as it can improve grip in wet conditions. Sulfur is a crucial ingredient. It's the key to the vulcanization process, which we'll get to later. It's a complex chemical cocktail, all carefully measured and mixed. Once all those raw materials are gathered, the natural rubber, the synthetic stuff, the carbon black, sulfur, and all the other chemicals, it's time to mix them up. This isn't like stirring cake batter in a bowl with a spoon. We're talking about industrial-scale mixing using machines that are absolute beasts. The most common piece of equipment for this job is called a Banbury mixer. Imagine a giant heavy-duty internal mixer with two massive, specially shaped rotors inside a closed chamber. The process starts by feeding precise amounts of each ingredient into the Banbury mixer. The rubbers go in first, then the fillers like carbon black and silica, followed by the various oils and chemicals. The rotors inside the mixer turn and churn, masticating and blending everything together under immense pressure and friction. The mixing process is done in stages. Different ingredients are added at different times to ensure they disperse properly and interact correctly. The goal is to create a perfectly homogeneous, consistent batch of rubber compound, often called master batch or final batch, depending on the stage. After mixing, the hot rubber compound is dropped out of the Banbury mixer. Now that we have our perfectly mixed rubber compound, it's time to start making the actual parts of the tire. A tire isn't just one solid piece of rubber, it's a complex assembly of different components, each with a specific job. One of the first things to be made is the bead. The bead is a strong, hoop-like structure that anchors the tire to the wheel rim. It's typically made from high-tensile steel wires, coated in rubber and then formed into a ring. Next up, we have the body plies. These are layers of fabric, usually polyester, rayon, or nylon cords that are coated on both sides with rubber. These cords give the tire its strength and flexibility, forming the casing or skeleton of the tire. Then there are the belts, which are typically found in radial tires, the most common type for passenger cars. Belts are similar to plies but are usually made of steel cords, also coated in rubber. Finally, we have the tread and sidewalls. Each of these components is carefully manufactured to precise specifications before heading to the assembly stage. With all the individual components prepped and ready, the beads, the plies, the belts, the tread, and the sidewalls, it's time for the main event, building the actual tire. This usually happens on a specialized piece of equipment called a tire building machine. Think of it as a sophisticated rotating drum that expands and contracts, allowing skilled operators or robotic arms to precisely apply each layer of the tire. The process starts with an inner liner, a layer of special rubber, often butyl rubber, that makes the tire airtight. Then, the body plies are applied, their edges wrapped around the bead wires, which have been positioned at either side of the drum. Next, the steel belts are applied over the body plies in the tread area. These belts add rigidity and strength, helping the tire maintain its shape and providing a stable foundation for the tread. Finally, the preformed tread strip and the sidewall sections are applied. The tread is wrapped around the circumference of the belted casing, and the sidewalls are positioned to cover the body plies from the bead to the edge of the tread. At this stage, the tire looks like a tire, but it's still green, meaning it's uncured, soft, and sticky. So, we have this green tire. It's assembled, all the layers are in place, but it's still pretty floppy and not very useful. To transform this soft, pliable assembly into the tough, resilient tire we know, it needs to go through a process called vulcanization, or curing. This is where the magic really happens, thanks to that sulfur we talked about earlier, along with heat and pressure. The green tire is placed into a curing press, which is a massive machine containing a mold. The inside of the mold is engraved with the tire's tread pattern and sidewall markings. Once the tire is inside, a flexible bladder, kind of like a heavy-duty inner tube, is inflated inside the tire. This bladder pushes the soft green tire outwards against the heated mold with tremendous pressure. Under this intense heat and pressure, the sulfur and other curing agents trigger a chemical reaction. The long, tangled chains of rubber molecules begin to form cross-links with each other. This cross-linking process is what gives the rubber its strength, elasticity, and durability. The vulcanization process can take anywhere from 10 to 25 minutes, depending on the size and type of tire. Once the curing cycle is complete, the press opens and the bladder deflates. The now fully formed and vulcanized tire, complete with its tread pattern and sidewall markings, is ejected from the mold. Let's delve a little deeper into that curing press and what it does, because it's more than just a hot box. The molds themselves are incredible pieces of engineering. They are usually made in segments that come together to form the complete shape of the tire, including every tiny sipe and groove in the tread pattern. When the green tire is placed inside, and that internal bladder inflates with steam or superheated water, it forces the soft rubber to flow into every nook and cranny of the mold. The combination of high pressure and high temperature during vulcanization is what sets the tire's final shape and characteristics. The heat accelerates the chemical reactions involving sulfur, creating those vital crosslinks between polymer chains. The pressure ensures that the rubber is dense, free of voids, and perfectly conforms to the mold. After the specified curing time, the pressure is released, the mold opens, and the tire is removed. The tires are then typically conveyed to a post-cure inflation station. Here, they might be inflated and allowed to cool under controlled conditions. This helps the tire to stabilize its shape and dimensions as it cools down, preventing distortion. The transformation is remarkable. Making a tire is one thing. Making sure it's safe and reliable is another entirely. After vulcanization and cooling, every single tire goes through a rigorous inspection process. Quality control is paramount in this industry, and for good reason. People's lives depend on these things. The first step is usually a visual inspection. Trained inspectors meticulously examine each tire, looking for any cosmetic flaws, blemishes, or defects in the tread, sidewalls, or beads. But looks aren't everything. Many tires, especially those for passenger cars and aircraft, will undergo X-ray inspection. The tire is passed through an X-ray machine, similar to what you might see at airport security, but much more powerful. This allows inspectors to see inside the tire, checking for any internal defects that wouldn't be visible from the outside. Beyond visual and X-ray checks, tires are also subjected to uniformity and balance tests. A tire uniformity machine spins the tire under load, measuring variations in force and runout, how perfectly round it is. Finally, a selection of tires is pulled from the production line for more destructive testing. Only after passing all these checks is a tire ready for the road. from raw rubber and chemicals to a life-saving component, a testament to human ingenuity, machinery, heat, and pressure. You might never look at those black circles the same way again. They deserve respect for the dirty job they do, keeping us connected to the road. 4 patches of rubber transmit all forces of acceleration, braking, and steering. They absorb shocks, contribute to fuel efficiency, and handle wet conditions. Appreciate the incredible journey of your tires.